Well, good morning, great to see so many of you here. Already dying for lunch probably, and now you want to know about FHIR servers. That's amazing. I will be talking about integrating a FHIR server in your architecture. So what is a FHIR server, etc. The question being, I want to integrate some system, but where does this FHIR server go? What does it do? What is a FHIR server actually? I started out with this talk because to me it was kind of obvious because I work with FHIR servers all the time, but it turned out not to be too obvious for all my customers. So I thought maybe more people want to know this. It turns out that's true. The audience, that will be you. This is a high-level talk, not high-level on difficult in terms of FHIR, but it will not be detailed into the code. So I guess you may be architects or integrators or maybe developers want to know what to do with the FHIR server. There's no code involved. You want to have code, you should come to my next session. This is me. I'm from FHIR. I've been developer, analyst, architect, or whatever you need me to be. And for a couple of years now, I am the lead developer of our own FHIR server. And you can reach me by email, by Zulip, or wherever. So what is a FHIR server? So that's what we're going to talk about. How can you use it? And what architectural patterns can you use? It's actually not too hard once you know it. We're going to combine the use cases and the architectures to set some examples on how you could use this in your own environment. And of course, you can ask questions, and who knows, we'll have answers. First, the FHIR server in the specification. The funny thing is, there's a lot in the specification that has its own page. Not so for FHIR server. It's all over the spec, but you really have to look hard to find a description of what it actually is. You can't read this because it's just about FHIR servers. This also, but then the interesting part comes on the architecture overview page. Well, if you're an architect, that's the first page you read, of course. It says a FHIR REST server is any software that implements the FHIR APIs and use FHIR resources to exchange the data. Well, that's pretty clear if you know what the FHIR APIs are, and if you know what FHIR resources are. By now, I think people who didn't know what FHIR resources were will have taken the introduction tutorial by Richard. And here's something about the API. So here's the FHIR server definition that we use here. It's any software that implements all or some of the parts of the FHIR RESTful API. And the list next to it is from the specification, so you can look that up. It lists all the methods that are in the API, like reading resources or version reading or providing history. Obviously providing a capability statement. Search, very difficult one. The interesting thing about that capability statement is that is actually the only thing you really need to do to be a FHIR server. If you publish an empty capability statement, you have a FHIR server. It's not useful, but it's a FHIR server. But what else are FHIR servers for? The actual idea in the specification of FHIR is you want to enable apps, portals, exchange mechanisms to consume FHIR resources easily, to find them, to update them if necessary. But there is a lot of detail in managing all those resources, in making sure you don't get conflicts, making sure that if you search, you get the correct results. And the idea is let the FHIR servers handle all the hard parts, so the FHIR clients can be more simple and focused on the actual clinical results that they want to reach. So the FHIR server is for the heavy lifting. Here in a bit bigger font, the functions that are defined in the API for FHIR servers to do. First of all, capabilities, as I said, the very minimum you have to do. You should be able to store resources and read them back, so traditional CRUD methods. You could be able to do searching. By now you probably saw some search URIs by like searching patient by name or by its identifier. A server may support old versions of resources. So you don't overwrite them, but you keep the old versions. And then you can provide history on what has changed on this resource during the course of time. Also interesting in a research environment, if you want to point back to a point in time when the research results were published, for example. Validation is very interesting. So that you can, if you send resources to a server, it can validate it against structure, against a profile, against a structure definition. Let's say you're in the Argonaut project, your resources will have to validate against the US core profiles. It can support multiple formats. Defined in the spec are JSON, XML, and Turtle. Other formats are emerging, like protobuf. There's a session on that as well, I think tomorrow. And maybe even more. If you want to add more for yourself, you can do so, but those are not really defined by the spec. And they can also translate between the two. So if you send a resource in XML, ask it back in JSON, no problem. Then, transactions and batches. A batch is nothing more but a whole bunch of requests to a server bundled in a FHIR bundle. That's not too hard. You just do them one by one, and it's actually the same as doing them one by one. Transactions is a bit harder because they are guaranteed to succeed or fail together, and they can have links between them. Then you can provide custom operations. Those are the operations that start with the $sign. Actually, validation is one, $validate. So you can just validate to see whether your resources are correct. But there are operations to update your metadata, to do all kinds of things, and you can define your own. And all of that may be possible across different FHIR versions. A FHIR server may support only one version, maybe have 2 endpoints for 2 versions, or support multiple versions in one server. That's up to the server itself. This is all kinds of things you can think of that a FHIR server could do for you. Now, there's 2 types of servers. One is the generic FHIR server, and that is a server that will implement, well, it's a little too much, usually most of the RESTful API, all those functions I showed you before, for all types of resources specified in the specification. And they usually come with storage of their own. That could be a relational database, a document database, or whatever. And a couple of examples of this are, of course, the Happy or Smile CDR stack that works with Java, and a JPA to relational databases. There's 8box, which works with ProgSQL. Of course, there's Vonk, that works, that's the .NET stack, and it works with SQL or Mongo. And Graham server is a generic FHIR server as well, which is on test.phir.org. The other one are specific FHIR servers, and they implement just a bit of the API, just the things that they need. Usually with only for a couple of resources. Let's say you have a laboratory system, and you want to open that up to FHIR, then you're probably not interested in all kinds of resources, but just the ones related to lab and lab results and orders, etc. So specific FHIR servers are often found to an existing backend system. could be an EHR, which is very large, as you see Epic and Cerner and McKesson are working on. It could be smaller, like a laboratory system, or maybe even a departmental system, like the one on access that's behind the desk of the doctor. And you can also see this as a FHIR facade to that system. So you bolt on a FHIR interface to it. And they may have specific operations also. So if this is an appointment booking system, you could say, get me the free slot, which is something you can ask there, but not on some other system. We're going to go through a couple of examples. I'm going to present the examples first, and then do the architectures, and then we're going to combine them together. So the first one is external data reporting. For instance, you probably, in Holland, we report to the RIVM, which is something like CDC here. A lot of hospitals report similar data to a government institution. Or another case is that you want to support a portal that you want to set up, and it has to be fed from different sources. Or you want to support an app platform to build your apps on. A clinical data repository, collecting all the data from different sources for research, for example. Or just system integration. The lab system wants to know something from the appointment system, and the appointment system wants to know something from the EHR, etc., etc. Now, what could that look like? I'm going to give you an abstract view of what this looks like to give you a means of reasoning about this. And we use these symbols. We have a source that has data that's interesting to other systems. We have a consumer that are interested to have that data. A small arrow is requesting data, and the big one is for a data transfer, either as the response to a request or a push. And then these gear icons are for transforming either the request or the data. For those who are into architecture and enterprise integrations, I've included some of these patterns as well. If you don't know them, that's not a problem for the rest of the talk. So we'll start simple. We have a single consumer, and it needs a bit of data from a source. Well, actually, if it's this and you're not extending this in any way, you might not need FHIR. But it's a simple use case to go by. So where then do you put that FHIR server? There's essentially three methods. One is you put a facade on the source. So you make sure that you can address the source system, which may be that lab system, with a FHIR API. You have to program the facade on top of that system. The second way would be to put a generic FHIR server in the middle of it. So the source pushes its data to that generic FHIR server, and then from then on it can forget all about it, and then the consumer can use all its FHIR power to query that generic server. And then the third one is to put the facade on the consumer. So that becomes a FHIR server that you can push data to directly. Well, these are the three basic ways to do it, and we're going to vary upon this. But let's get into detail of these three. The first is the facade on the source. So you put the API directly on the source, which means that here you see my mouse? No. That here, this is native. So if there's a SQL database here, this will be SQL queries, and this will be a data set. If there's another web API here, this will be URIs, and this will be JSON, XML, or whatever you return. And then you build a facade on top of that, and it has to do two things. if you want to read data on this facade, and you want, because the source has the data, then the consumer should be able to search for that data. So it might search for observations by a certain code. That means, but you can't search for observation by a certain code in the FHIR way on this source. So you have to translate that query that comes in into something that your source will understand. You translate it to a SQL query or to another web API call. Then when the data comes back, the source probably doesn't give you FHIR resources. If it did, you didn't need the facade. So you have to map that data back to FHIR resources before you return it to the consumer. So there's two mappings involved. But once you did that, then any consumer can use that FHIR API. And it's perfectly fine if that's only for 3 resources and 5 search parameters, as long as your capability statement states that is the case. Generic FHIR server. This is actually pre-aggregation. But that means you have a copy of that data, and a copy of data means that it may be delayed, or you may not allow copies of data for some security reason. But if you do it this way, you have to have a copy of the data. There's an advantage to this. You only map the data out on the source system. So whenever data becomes available here, or by cron job, periodically, whenever you like it, you push that data out to that FHIR server, and it will store it for you. And generic FHIR servers tend to have the capability to support all the search parameters on those resources. And you don't need to do anything for it, except installing the FHIR server. So now the consumer can just query the FHIR server and get resources back, and the resources were already transformed here, and they are stored as resources in this system, so they just get the data right back and transform it to their own liking. So in this case, you need a FHIR client on both sides, one to send the data and one to query for the data. Yes, so we have a question. Sorry?
How does this deal with rights?
With rights? Yes. Authorization, you mean?
No.
Oh, rights. Updates. Yeah. How does this deal with updates? This does not deal with updates because there's no way back here. If you want that, there's 2 options, actually. One is if you did, because here it's clearer. If this is a FHIR server, you could implement rights as well. Right here, that's not so clear. There's 2 options. One is rights go in the FHIR server, and this is going to query the FHIR server for updates to process on its own side. Or this will act as a router to send that data along here, but then you still need a facade here to process that. So this is not an ideal solution for rights. A facade would make that clearer. Yeah. And then finally, you could put the facade on the consumer. And effectively, that's also about writing data, because that means the source has data that the consumer wants to have, and the source writes it to the consumer. And that is possible here if you have the facade on that side. In this case, you don't need to translate all the search capabilities, because it's only writing. And this will have to transform its data to a FHIR resource. This will accept that and translate it to an internal format that is understood by the consumer. That looks deceptively simple, except that doing writes on a system is usually a lot harder than reading it, because you have to honor a business process in the system. Usually you're not allowed to write it directly to the database without messing up the database. And as we have with the FHIR server in the middle, we have this active component here that should make sure that the data goes to the consumer without knowing when the consumer might need it. So that's the three basic patterns. Now we can have multiple sources. And now the consumer is the integration point, as it is now. We have a couple of sources. Consumer needs data, it queries all the sources, and it pulls that data, so the consumer is the active party here. And it may need to ask all the sources to get its data and combine all those responses. Now, what if we would put facades on the source here? So that's the first option, but then with multiple sources. The advantage to the consumer is that it has only one mapper left, because it doesn't have to deal with both source formats. Effectively, you could replace a source as long as it still emits FHIR. There's no change to the consumer. The consumer is still the integration point. It might get conflicting data from both, and it has to know how to deal with that, because they don't know it from each other. So it's also the aggregator of the data. These aggregators get together. That's the integration patterns that apply here. And the source systems, they become FHIR servers, and they have to do all that mapping, both of the search queries and of the data, as we saw in the simple case. An advantage of that is you keep the mapping of the data, you keep it to that source. So if you replace the source, you replace the mapping, and you create a new facade. We could also do this with a generic FHIR server. And it's essentially the same as with one source, except that two are now pushing it. And you probably need a bit of logic on that FHIR server to handle conflicting data. Well, the simple version is version your data and just pick up a new version. But it's usually not that simple in the hospital. And you still need very clear rules about what system is the owner of what type of resources. So the HR may be responsible for the patient resources, and the lab system may be responsible for the lab results and not the other way around. You still have a copy of all that data in the FHIR server, just as in the previous case. Things become a lot easier for the consumer here, because it only needs to deal with the FHIR server that already dealt with conflicting data. Final, you could probably guess it, is make the consumer the facade again. Now the sources have to push to both have to push to the consumer, and you see it's getting a bit more complicated here if the number of sources is increasing and if the number of consumers is increasing, because then the sources have to know which consumers to address, etc. And before you know it, you have an integration engine in the middle to make sure that every resource is sent to the right consumers that need to know about it, a bit like we do with V2 currently. But we still have, also in this case, we keep the mapping of the source data at the source system, and we map the mapping to the consumer system at the consumer system. So that's the trick, to make it a bit manageable. Consumer is still the integrator here. So again, it has to deal with all that conflicting data. But the consumer can now also support the creates and updates, so you can write the data to it. Well, you can infinitely combine these things. You could make facades on the source and then put a generic FHIR server in the middle, which essentially makes the FHIR server a router. So it gets a request, it routes it to the various facades, gets the data, combines it in a single response and sends it back to the consumer. You still have to make sure that that FHIR server in the middle knows how to handle conflicting responses, but now real time. But the FHIR server needs no storage, so that's the advantage here. You don't have the copy of the data, it's always real time. Well, more sources, more consumers, you get this kind of picture. And I guess you know where that goes. I'm not going to draw a picture of all the options in this case. But the mapping explodes. And you don't want a point-to-point connections, just as we don't want that now. Now, if we map this to the examples that we had, what do we get? First, the external data reporting. How would we solve this with FHIR? First of all, the source is obviously the hospital, the consumer is the government. We could put a FHIR server at the hospital, it maps its data to that FHIR server, and the government just asks for it when it needs it. It's helpful because it offloads the query things from the source system here. It only needs to map out, it doesn't support the querying on the source, and the consumer can get it whenever it needs it. But every hospital needs that FHIR server to be able to query the data. What if we move the FHIR server to the other side? Then we need only one. That might be better. Also, not all health institutions like you to query inside their systems or beyond their firewalls. That is also solved here because now the initiative is at the source and it sends to the FHIR server of the government institution that wants to know it, just the data that it thinks it should send. So that might be a safer option. The case for portal support. One option is to put facades on all the sources. And then whenever the portal needs something, it just queries all the sources. And they have to do a lot of mapping. The advantage being that if another system comes by that wants to query these sources, it can use the same facades. Another option, and it clears up the picture a little, is to put a FHIR server in the middle, let them push that to the FHIR server, and then when the portal needs something, it gets it from there. Depending on how real-time your portal must be, this is an option. If it has to be real-time, this is a bit harder, because there is always a delay in this copy. You want to support an app platform. Well, if you do that, you choose FHIR because it was invented to support apps. You just put a FHIR server here and they can all query that. That gives the question on how does that data arrive here? Well, that's basically the previous slide. So you could see this one as the upper level of this one. The apps still have to map the data, by the way, to their UI or their internal model, or most apps are not natively FHIR. The clinical data repository. This one has an interesting extra option. The first one, maybe the obvious one, is to make this turn this into a FHIR server and then have them send their data in FHIR format. A FHIR server may have the option to retain history, which is very interesting for a clinical data repository, especially for research. And the source systems push the data. A delay is usually not a very much of a problem in a clinical data repository. It's not up to the minute, but every half hour will be sufficient. But the other option, and we actually did this for customers, is they already have a data repository in place for their BI systems or their medical intelligence systems. And they gather all that data right from the database with ETL mechanisms. That's usually a lot faster than creating FHIR resources, sending them over an HTTP connection. So let them do that, integrate that data, and then put a FHIR facade on it for other people to consume that data. And this works. And the final one we had was systems integration. Well, this maybe the obvious case would be as you put an integration engine in the middle. Currently, you would put a FHIR server in the middle here. But these systems now have multiple roles. They are the source of data, but they may also be the consumer of data. And they can. This is the easiest way to support all of this without getting crossing lines. Other option, give them all a facade and retain the point-to-point connections. If you have only 4 systems, this may work. If you're a proper hospital and have 400 systems, this will not work. I mentioned an integration engine a couple of times. What about them? Why don't I already have an integration engine probably in your hospital? Why can't you use it for this? Well, they often don't provide storage of resources. And they usually don't provide a REST interface, especially not the FHIR REST interface. But they can come in handy because they can provide scheduling. And they're pretty good at mapping usually. So you could use them to do parts of that facade. Or if a system has to push data, it has to be an active component. It has to run scheduled. And then your common integration engine can push that off, can start the process. It can also be a router for if a resource has to be sent to multiple FHIR servers or queried from multiple FHIR servers. You can probably configure that in an integration engine because that's what they're good at. So that makes it also a better fit for a message broker solution. And whether that message is then in FHIR resource format or some other format is less important. Which takes me to messaging. Because messaging is another paradigm in FHIR. FHIR is not just REST, it also has messaging. It has defined service-oriented architecture, which is kind of a collection of all the things. But messaging. The trick here is that not the provider of the data must be online, but the consumer must be online because it gets that data sent to it whenever it is or is not ready. And the source determines the contents and the granularity. If you have a FHIR server as the source, then the consumer gets to determine what it asks for and what not. But if you send messages, then the consumer will have to deal with whatever is in the message, whether that it's too little, too much, or both. But it does allow for a better workflow, because REST is not very good at providing, it's just request and response and that's it. And for messages, you can provide a complete workflow with all kinds of messages going back and forth, creating a complete sequence diagram. But you can still do the messaging with the FHIR resources. If you want to know more about that, there's another session on that tomorrow at 9 o'clock by Renee, who is not here anymore. So what are the considerations to make a choice? First of all, do you allow incoming requests? If you don't, Don't pull up a FHIR server because no one can reach it. Do you allow delayed copies? And what delay is acceptable? Or don't you allow copies at all? Do you control all the participants? Because I sketched the systems, but I didn't sketch really where they are. Because in the external data reporting, you send it out of your organization and you don't control that side. If you control all the systems, you have a lot more choice. Who has the initiative? Should someone send the data if it becomes available? Should someone send it periodically? Or is it just data at rest and it gets queried whenever necessary? If your data is queried once a week, it's probably not very useful to send it whenever it becomes available, just to get it to the other side. And to avoid conflicts of data, who's the primary source of truth? As I said, if two systems have the same claim to be the owner of the data, then you have a problem. And that's an architectural question, and it's not specific to FHIR. And last, but maybe not least, what are the development capabilities of your team? Because developing a FHIR facade takes time, effort, and skills to do so. There are helpful tools to make that work in all kinds of environments, Java, .NET, JavaScript, but you still have to program things, map that data, so you really have to know what you're doing. And if you're addressing your source system, you should make sure that you don't stress it out because it's being used for other things. So the answer to the original question, where does this FHIR server go, is, as always, in our profession, it depends. That leaves us with a couple of minutes for questions.
So in practice, do you typically see a generic FHIR server or one that's implemented on the consumer or the source side?
It varies. We have seen generic FHIR servers. We also have seen facades. Because if you don't have access to if the source system cannot do pushes, can only be queried, then you have to put a facade on it to make sure. No, on the source side. Yeah.
What components of the facade? I mean, is that like half a FHIR server? Like what's necessary to make a facade?
What's necessary to make a facade? Well, actually, that is, they usually provide the FHIR REST API part and leave the data mapping up to you. So you have to plug in your data mapping. That's the way it works in Happy. It's the way it works in Vonk. But you don't have to check whether all the URIs are correct, whether the syntax of the search is correct. They can provide formatting of your data, so the serialization in different formats. They can tear apart transactions maybe. So that's what the facade does for you, and then you just implement the connection to your data. Are you asking about the translations or the transactions?
No, so in the typically when you report lab results, for example,
yes.
or for that matter, the diagnosis codes, those codes are specific to the system from which they are coming.
Yeah.
So my question is, when you report it in the resource format,
Yeah.
I'm assuming that you won't really send 0, 1, 2, 3 the way it is, right? And that's what it is. There needs to be some kind of a cross walk, which would say that 0 in server means this, 0 in epic means this, or...
Yeah. I think you're referring to managing your master data. And that doesn't go away here. The only advantage of FHIR is that you could include multiple equivalent expressions of the same things. Equivalent expressions of a quantity, of a code, in different code systems. But then still you have to address that the consumer may need another system than the source can provide. And you will have to integrate some kind of terminology server to make that translation. Yeah. Yeah, a FHIR server might be able to do that lookup and add it to the resource before it is queried by the consumer. Yes, thank you very much. Enjoy the lunch.